As part of ITU's International Telecommunication Union International Training Program, ITP, which is held in Kuala Lumpur, Malaysia, the 28th to 26th of August 2015, is here a presentation about the wider cybersecurity risks practices for policymakers and regulators. This event is co-organized and hosted by the Malaysian Communications Multimedia Commission, MCMC, KKMM, and supported by the Australian Government Department of Communications as well. This presentation is provided by Globeron. What is covered here are the Wi-Fi wireless service availability issues, the Wi-Fi mobile, cellular and other wireless security issues, governance, standardization and certification, examples of governments in APAC adopting standardization and certification of personnel, wireless service and security management system. To understand wireless security, first we need to look into the Wi-Fi wireless service availability issues. Unfortunately, we cannot show all the issues we have in wireless networks, but here is one of them, an outdoor installation in an Asian capital. So you see a lot of cabling here, and try to find the access points which have been installed in this scenario. It's actually used for CCTV camera distribution video signals over the city. Now if you look in the right picture, you can see two access points with some antennas connected to it, but you can imagine that it is not the ideal situation to install a deployment like this. Similar here for outdoor installations, typically a NEMA enclosure is used, or an IP rated enclosure. That means how can you protect your equipment against rain, dust and other environmental situations. In the picture on the left you see, for example, two indoor access points installed in an outdoor environment. So you get all kind of issues that the access points start to reboot because it get overheated, and you see that it is not a nice installation here as well. On the right side as well, now we're using outdoor NEMA enclosures in an indoor environment, and you see two antennas poking out of it. So they actually make use of a NEMA enclosure for security reasons, that people don't steal the access point, but that is actually not the purpose of it. Now it is not only about the installation of all the wireless equipment, also it is the way how it has been configured or how it has been deployed. So here we see in this picture a lot of overlap. All those access points are interfering with each other, actually competing against each other. And the best way to compare it is if you go to a meeting or a conference where there are many people together and they all start to shout against each other. Then it will be very difficult for a person to do a presentation to this crowd because there is a lot of noise. So that is actually happening here as well with those access points, and it will be very difficult for Wi-Fi clients to connect to those access points. So they create disconnections. Now why is that important? Because of business critical or mission critical installations that will have an effect on the communications. As wireless becomes so important, we also need to look into the RF, the radio frequency coverage planning for indoor and outdoor environments. So you see in these pictures, for example, from how do we make sure that those signals come into the buildings. So think about cellular or mobile type of environments. How that signal can penetrate into a large shopping mall or in a high density city, or for indoor environments where Wi-Fi networks have been installed, how can you make sure that that signal can reach all the clients as well. Think about fire rated doors, thick construction walls which are absorbing the Wi-Fi signals, and that might give issues to reach those clients which are maybe at the other side of the wall. In certain parts of the world there are high density cities where there are millions of people living very close to each other, and also because the way how they do business, they may be 24 hours on the street. The persons carry 2-3 wireless devices with them, and that is all going to compete against each other. Also with the mass deployment of Wi-Fi devices in hotels, apartments, shopping malls, public Wi-Fi networks, it's only getting worse. And that's all going to compete with each other. So we actually create one big Wi-Fi zone in the city. Now there is probably no channel coordination between the internet service providers, and how to do that when people install their own Wi-Fi access points at their apartments or in the hotels. There is no proper coordination between the public networks and the private networks as well. The other question is 2.4 GHz for Wi-Fi, is it enough? And is 5 GHz enough? Because people will take that spectrum. So we need to look into other spectrums as well, for example TV, white spaces. But it probably will not be enough, because once it's there, people will consume it. Now, to design a wireless network, there are many items to take in consideration. How to design it, how to implement it, and how to operate a wireless LAN network. So we have to look into the IEEE standards and the interoperability with newer standards. For example, the 802.11ac coming up. Now we have a Wave 2 version, which stands for multi-user MIMO, multiple input, multiple output. We have to deal with modulation complexity. Probably the wireless devices need to be closer to the access point to achieve a better result, a better throughput, a better speed. We need to look into the alignment of the antennas. Do we really need to use omnidirectional antennas, or do we need to use highly directional antennas? Think about stadiums where many people are sitting in a close proximity. So different type of antennas are probably needed. We need to look into the frequency selection, the channel bandwidth, signal strength and noise values, channel plannings, the capacity planning, especially for high density areas. We need to survey those areas from where we're going to install those access points. Cabling requirements are important because that's the backhaul of your wireless network, but that also impacts the power over Ethernet, the requirements, because some of the access points have multiple radios built in. Then we have access points, APs, mesh access points, controllers, cloud controllers, controller-less environments. Quality of service need to be guaranteed over a wireless network to provision voice, video and data type of communication. But actually that is moving to QoE, quality of experience. That's how the end user perceives the wireless network performance. Portability versus mobility and roaming requirements becomes very complex, especially when you have to roam between different service providers. Wireless management tools need to come in place to do compliancy and reporting, and security need to be integrated into all those designs, and that can make it a little bit more difficult to create an end-to-end secure network. It's not only Wi-Fi we need to look into, there are also other wireless technologies. So a mobile cellular radio network, well, we have the 1Gs, the 2Gs, the 2.5G or Edge, HPDA, 3G, 4G, LTE and LTE-U in unlicensed Wi-Fi bands coming up. It's becoming quite complex how to do the coordination for those cellular networks as well, and to provide good quality wireless networks. We have to deal with network function virtualization or NFV and SDN software defined networks as well. And there are also other type of wireless networking devices. Think about home automation, or in car technologies that make maybe use of Bluetooth. You have to deal with RFIDs, Zigbee, NFC, near field communications, microwave communications, satellite and so on. Now we've seen actually the top of the iceberg from how complex it is to do a wireless design and the deployment of those networks as well. We look now into another aspect, like for Wi-Fi, mobile, cellular, and what are those related security issues. It is actually good to categorize the security and business impact levels. So here is actually an example of the Australian government, but it is focused on the business impact levels, but you can actually map it to security as well. So there are in this case 6 categories from how much is security going to impact your business critical services. So is it a low impact, a medium impact, a high impact, a very high impact, an extreme impact, or is it catastrophic? Here are some examples of wireless vulnerabilities focused on Wi-Fi. Not all of them will impact your wireless services or has a big security impact, but it is related to it. So reconnaissance, basically scanning around, observing the vicinity, maybe to detect rogue access points, illegal access points which should not be in the operational environment, open or misconfigured access points, ad hoc stations, which are broadcasting and impacting your services, to do sniffing and eavesdropping, to detect certain vulnerable security implementations, like for example WEP, Wide Equivalent Privacy, or WPA, Wireless Protected Access, or LEAP, Lightweight Extensible Authentication Protocol, which is actually vulnerable to a cracking methodology. Also, dictionary attacks, brute force attacks, rainbow tables can actually help to find those passwords which have been implemented in those wireless networks. And some access points they broadcast a lot of information, and that can be captured. Masquerade, MAC address spoofing, that means actually copying someone else's MAC address that need to be detected. Hotspot attacks, evil twin or Wi-Fi phishing attacks, that means that people set up access points with the same server set identifier, so it looks actually like a legal access point, maybe people connect to it, but that need to be mitigated. Insertion attacks, multicast broadcast injections to stop certain communications, routing cache poisoning, also to divert traffic to certain areas. MITM, man-in-the-middle attacks, that is actually related to the evil twin attack as well, where clients also get disconnected and wireless traffic is diverted via a man-in-the-middle, so he can actually see your communication. Denial of service attack is more catastrophic, so that can be a disassociation attack or a duration field spoofing attack, or an RF jamming attack, and that all is going to impact the communication between the clients and the wireless service provider. Similar, in the mobile and the cellular environment, we have wireless vulnerabilities as well. So here we have the same type of categorization. So reconnaissance, you can think about baseband fuzzing or detect rogue BTS, baseband transmission systems. And actually mobile or cellular traffic can be diverted to these rogue BTS systems. Sniffing or eavesdropping, well, telcos, they have protocol analyzers. In general, the public don't have those protocol analyzers for a cellular or mobile network, but you can obtain one, but it is not that obvious as in the Wi-Fi space. But now there are also software-defined radios, SDRs, which can actually tap on those networks. Masquerade, so the IMEI spoofing can be done. Insertion, IMSI detects, so that are IMEI and IMSI, that are some technical terms used in mobile equipment to uniquely identify the equipment or uniquely identify a SIM card as well. Denial of service, so request for channel allocation, flood the BDS and the BSC as well. RF jamming, IMSI flood for pre-authentication or overloading the home location register or the visitor location register, IMSI detect and disconnects users. Now, and there are many more issues as well. Similar for other networks like Bluetooth, NFC, ZigBee, Internet of Things, we see issues as well. So in Bluetooth we can have viruses, worms, malware, listening to phone calls or the communication between the headset and the car audio systems. Maybe a system gets hacked to control the car via Bluetooth devices. You can change languages, that's actually a denial of service attack. People can maybe not read Chinese and it takes a while before they can put their phone back into the English language. NFC, near field communication, credit cards with NFC communication built in, transportation cards like the bus and the train, toll gates using wireless cards, hotel key cards, ZigBee for home automation equipment and floor controllers, thermostats, Internet of Things, Internet of Everything, limited security capabilities are available in those devices. So maybe the security mitigation techniques for IoE or IoT becomes very complicated. So far we have only been looking to the wireless or mobile cellular infrastructures, but what we also need to take into account are the operating systems itself. So like the Android OS, the Apple iOS, they can be rooted, wrong type of software can be installed, and that's all going to impact the communications. Applications can be enabled, like access control to the device, to enable the camera or to get access to storage, where a lot of important information is stored on your mobile device. Remote command and control. Hackers, they make use of certain techniques where they can have access to your mobile phone, maybe to get access to banking accounts for the authentication process. And of course malware can be installed very easily. So what is the next step? So we need to look into the governance, standardization and certification. So starting at governance. So governance is to establish a strategic direction, execute the strategy and manage the risk, and ensure compliance with policy, standards and procedures. Now if you look to the governance and we take for example a telephone system as an example, is it allowed to eavesdrop someone else's telephone connection via a wired telephone? No, in many countries that is not allowed. But is it allowed if someone taps your Wi-Fi connection and captures all those data? In many cases, in many countries, that has not been regulated. So governance is required, some policies and procedures. Standardization is important, especially for the design and the implementation and the security of a network, that it can be managed and that it can be audited, so that we actually know what type of service is provided. For example, is it 5-star, 4-star, 3-star, 2-star or 1-star, determining the quality of those networks. Important is to have certified professionals, not only to get the certification, that's one thing, but the certified professionals need to have practical experience. At least all those basic issues we have in wireless network, like interference or configuring access points on the same channels, or not mounting the access points properly, that should go away the more and more we have certified professionals. And last but not least, we require certified auditors actually to verify if those installations and designs and security has been implemented properly, in line with the standardization and in line with the government policies. Globeron came up with this slide. Actually, we see it happening out already, to build standardization at the national level per vertical market. So the government need to be in place, so the regulations and the policies need to be in place. And typically a government of ICT, the Ministry of ICT, should actually work with other government agencies. So think about the Land and Transport Authorities, the Ministry of Finance, Ministry of Education and so on, for each vertical industry actually address from what are the wireless and mobile security requirements, because it is different for each industry. If that has been put in place, that should move on to the enterprises to comply to. But not every enterprise has specialist or wireless specialist in the organization, so they probably need to engage external human capacity to that organization to be compliant. Now some of the governments, what they put in place is supporting schemes with funding to actually train people to get certified in wireless design or wireless analysis or wireless security, to help actually the industry for that particular vertical market to get certified. But more important is actually how you can implement a good design and a good security for that organization. So that will improve the wireless communications for business and mission critical networks. There are different international organizations who take care of standards. Usually that includes much more than wireless only, but here are a few of those organizations. The IEEE, the Institute of Electronics and Electrical Engineers, standards like 802.11, which takes care of Wi-Fi, 802.15 is Bluetooth, 802.16 wireless broadband. The Wi-Fi Alliance, these are the vendors which are grouped together to take care of interoperability between different type of Wi-Fi devices. 3GPP for cellular and mobile traffic, and to provide data traffic over those communication methods. The IETF, the Internet Engineering Task Force, take care of internet standards, but that also relates to wireless networks. For example, authentication using radius, which is defined in an RFC, a request for comment. The Wireless Broadband Alliance, the ITU, the International Telecommunication Union, which have ITU-T standards. And then we have the ISO, the International Organization for Standardization, usually works together with IEC, the International Electrotechnical Commission. Another important international standard is the ISO IEC 20000, which is the first international standard for IT service management. However, not many people are familiar with this standard. Originally it came from the BS 15000 standard, the British standard. Then it became a 20,000 standard in 2005 and it has been renewed in 2011 and 2012. The 20,001, that are the requirements, and the 20,002, that is the code of conduct. So the IT service management system, which is applicable for all your IT services in your organization, is also applicable for a wireless service and how to do proper management for these. So that's indicated in the green rectangle. On the left side we have the customers and other interested parties which have their service requirements. So for example, do we need to provide voice or video over a wireless network or only data traffic? Then the service management system, that needs to be set up by the organization providing those services. So we have to deal with management responsibility to establish this service management system. We have to deal with governance of processes operated by other parties, documentation management, resource management, who is involved to manage this wireless service. Then we need to design and do the transition of new or changed services that need to be managed properly. And we have the service delivery processes. So that has to deal with capacity management, service continuity and availability management, service level management, service reporting, information security management, but also financials in relation to budgeting and accounting services. Then we have control processes, which deal with configuration management, change management, release and deployment management of your wireless network. Resolution processes, so this is the help desk doing incident management and service request management and problem management. Relationship processes, business relationship management and supplier management, because your wireless service probably depends on other services as well. And this whole system will then actually deliver the services to the customers and how they experience the quality of the services you provide to them. In relation to the IT service management standard, we also want to look into the organization's capability levels and into the service level agreements, the SLAs. So at which level do you provide wireless service management to your customers? And that can be internal customers or external customers. So there's a good slide of Gartner from 2006 indicating in 5 different levels the state of your organization. So if you're level 0, then your organization is very chaotic, it's ad hoc, undocumented procedures, is unpredictable, multiple help desks are in place, minimal IT operations, and the user is calling your organization to see if those wireless services are working or not. Level 1 is reactive, so it is best effort, still you're fighting fires. There is maybe some basic inventory in place, so we actually know what are the components of your wireless service. You initiate some problem management processes, alert and event management is in place, and monitor the availability of your network, usually up and down management only. Level 2 is proactive, so now we can monitor the performance and we can analyze trends. So now we can actually see that maybe every Monday morning the network is congested and we can take action on this proactively. We can set thresholds, we can predict the problems, we can inform the end user if problems are going to appear in the near future. We have a mature problem configuration and change management process in place. Level 3 is about service management. So now we define the services, the classes and the pricing. So for example, in a telco environment, if a telco provides wireless services at different speeds, like a lower speed, a middle speed and a higher speed, we can charge a different amount of money to each of those services. But how are they going to guarantee an SLA, a service level agreement to the end users? As most of you know, wireless is quite challenging, and it is easy to have a downgrade of your service. So if the telco in this case cannot provide the service, are they going to give you your money back for the service you subscribe to? So we need to set quality goals, key performance indicators, monitor and report on the services to do the trends analysis as well, and we need to look into the capacity of the network and do proper planning. Now that can be challenging as well, because it's not always so easy to increase the capacity of your network. Sometimes it can take 2 or 3 months time. Level 4 is more about the value of the service, the business. So the IT business and the metric linkage, the IT improve business processes, real-time infrastructure and business planning. Now what basically level 4 means that all your different processes we saw on the previous slide are integrated. So that means your incident management, your problem management, your change management, your release management, financial management, business continuity management, capacity management, and all the other related processes are working closely together. Now if the organization reaches level 4, then it can actually achieve ISO IEC 20000 IT Service Management certification. Another important international standard is the ISO IEC 27001 standard, originally launched in 2005 and has been revised in 2013. So the 27001 are the requirements, and the 27002 is the code of conduct, the guidelines. So this is a very popular standard for many enterprises, and sometimes you can ask yourself the question, what should be implemented first, the security standard or the IT service management standard? Well, this one is very popular compared to the IT service management standard, but our view is that the IT service management standard should be in place first, and then you glue in the IT security requirements into the IT service management standard. Now focusing on the telecommunications sector, the ITU, the International Telecommunication Union, came up with a guideline as well, set by the ITU-T. It's a manual on security in telecommunication and information technology, and is to provide a broad introduction to the security work of the ITU-T. So here you can find more recommendations how to improve the security for cellular and mobile networks as well. The International Telecommunication Union, in particular ITU-D, D for development, and IMPACT. IMPACT is the cybersecurity arm of the ITU, and Globeron work closely together to educate different members of ITU, so that includes governments and telco organizations, about wireless security. And recently we did a distance learning training for governments in APAC, so to talk about wireless security practices for policymakers and regulators. The next slide will give some examples of governments in APAC who adopted the standardization on certification of personnel. Singapore is the first government worldwide who adopted Globeron certification program, and in this case for the Wi-Fi certifications, Certified Wireless Network Administrator and Certified Wireless Network Security Professional, as part of the National Infocom Competency Framework, which is driven by IDA. IDA is the Infocom Development Authority in Singapore. As part of the NICF, the National Infocom Competency Framework, is the CTREP. The CTREP is the Critical Skill Development Program in Singapore, and the CWSP, Certified Wireless Security Professional, has been recognized by the Singapore government. The Malaysia government has a scheme in place which is known as PSMB, that is the Malaysian word for HRDF. HRDF stands for the Human Resource Development Fund, also to invest in their people to improve the skills for wireless technology, for in this case CWNA, the Certified Wireless Network Administrator. In Hong Kong, the Information Security Department, or known as InfoSec under the Office of the Government, also recognizes CWNA and CWSP. In the next slides we look into the wireless service and security management system. As wireless services grow exponentially and become business critical and sometimes mission critical for organizations, it's important that we manage those wireless services properly. So the wireless service and security management systems need to be in place and aligned with the standards. So we need to have a wireless service management standard, WSMS, which is aligned with the ISO IEC 20000 IT service management standard. And for security, the wireless service security management standard, WSSMS, aligned with the ISO IEC 27001 information security management system standard. To audit those standards is also important to maintain the quality of the deployments of those wireless networks. And that can relate to government-related networks, internally in the government, or public wireless networks provided to the end users, or internally in an enterprise to provide wireless services to the internal customers. No matter what wireless technology is used, cellular, mobile, Wi-Fi, Bluetooth, Zigbee, and so on, together we need to get better quality wireless networks for mission and business critical services. Now, to find more information, at item 1 there is a link to zoom into the wireless service management and audit aligned with the IT service management ISO IEC 20000. Item 2, wireless security management and audits aligned with the information security management system ISO IEC 27001. And standardization is needed to do wireless designs, wireless analysis, wireless security, and those standards need to be auditable to maintain and to get good quality end-to-end service and security management. Accreditation bodies for wireless services technologies are needed for cellular, mobile, Wi-Fi, so that's why it's important to work together with organizations like ISO, IEC and ITU-T. So hereby we hope to give a good overview of what is needed in the industry for wireless services to provide quality of experience to the end users. Hereby we would like to thank the ITU, the International Telecommunication Union, the Malaysian government, Malaysia Communications Multimedia Commission, and Australian government, the Department of Communications, by inviting Globeron for this international training program in Kuala Lumpur, Malaysia.